Nessler's reagent and its importance. This is today's lesson. In this lesson, we are going to learn preparation and importance of Nessler's reagent. So, let's get started. Nessler's reagent. Let us consider this is a beaker in which there is a solution of mercury 2 chloride or mercuric chloride. To this solution of potassium iodide is added. Instantly, with the addition of potassium iodide to the mercury 2 chloride, immediately a precipitate of red color is formed. The precipitate is like this. Potassium iodide reacts with mercury 2 chloride and as a result this precipitate is formed. Precipitate of mercury 2 iodide, which is insoluble in the solution. This is red in color, red precipitate, and potassium chloride is formed. So, with the addition of potassium iodide to the mercury 2 chloride, red precipitate of mercury 2 iodide is formed. When excess potassium iodide solution is added to this solution, that is excess potassium iodide, then this precipitate disappears. In this way, potassium iodide reacts with this precipitate, mercury 2 iodide, which is insoluble in the solution. Then this red color precipitate converts to potassium tetraiodo mercury 2. So this compound is formed, which is soluble in the solution. Its name is potassium tetraiodo mercury 2. Potassium tetraiodo mercury 2. Here 2, because in this compound oxidation number of mercury is 2. That is why 2 is used. Potassium tetraiodo mercury 2, which is soluble in the solution. Soluble potassium tetraiodo mercury 2 is formed. Now, this solution is made basic adding sodium hydroxide or potassium hydroxide. Sodium hydroxide or potassium hydroxide is added to the solution to make it basic. Now, this basic solution is known as Nessler's reagent. Nessler's reagent or Nessler's solution. This is called Nessler's reagent after German chemist Julius Nessler in the year 1856. So, this solution is named after German chemist Julius Nessler in the year 1856. Simply, Nessler's reagent is defined as basic solution of potassium tetraiodomercuric 2 is known as the Nessler's reagent. Now let us see importance of Nessler's reagent. Nessler's reagent: potassium tetraiodomercuric 2. Basic solution of potassium tetraiodomercuric 2 is known as Nessler's reagent. What is the importance of this reagent? It is used to identify ammonia gas and ammonium ion in solution. First of all, let us see identification of ammonia gas with Nessler's reagent. When ammonia gas is passed through Nessler's reagent, potassium tetraiodomercuric 2, when ammonia gas is passed through Nessler's reagent, then immediately brown PPT of this compound is formed, amino mercuric iodide, which is not soluble in solution. This is brown PPT, brown precipitate. This brown precipitate proves the presence of ammonia gas. Here, byproducts are ammonium iodide and potassium iodide. This is brown precipitate of amino mercuric iodide. In this way, ammonia is identified with the help of Nessler's reagent, potassium tetraiodomercuric 2. Now, let us see identification of ammonium ion. Suppose this is solution of ammonium ion, ammonium chloride, in which ammonium is present as ion. This ion is identified with the help of Nessler's reagent. In this case, base of Nessler's reagent first reacts with this salt, ammonium chloride, to form ammonia gas and sodium chloride, and water is formed. Now, this ammonia gas reacts with Nessler's reagent, potassium tetraiodomercuric 2, which is soluble in the solution. Then ammonia forms brown precipitate of ammonia mercuric iodide, brown precipitate. Here, byproducts are ammonium iodide and potassium iodide. This brown precipitate proves the presence of ammonium ion in the solution. So, in this way, Nessler's reagent is used to identify ammonia gas and ammonium ion in solution. Nessler's reagent, which is named after German chemist Julius Nessler in the year 1856. This is all about Nessler's reagent. No more today. Thank you very much.